Good morning, everybody. This is Mr. McWhorter, and I'm your Algebra 2 teacher. Hello, everybody. Hey, and I was wanting to give you the first of a few video lessons on how to complete the actual assignments in algebra. And I know that some of these were ones that you probably know quite a bit about already. All of this, of course, would be a review from Algebra 1, but I know that a lot of us took geometry last year, so it's been an entire year between the last time you did any algebra. So I want to let us get some of the rust cleaned off and some of the rust and dust, off of our algebra skills, and we make sure that we're all up for moving into the very first module, which has a lot to do with, number sequences and the domains and ranges and such of functions. All right, so I'm going to go ahead and show you the very first one, which, if you have that, it's the algebra review of skills needed for Unit 1. And the first page is called Analyzing Functions. And in the first one, we're going to do what we call rotations, and then after that, what we call translations. So I'm going to go ahead and move my camera here so that you can see what I'm working on a little better. Hopefully I won't mess it up here so that you can see. All right, this is our first paper right here, making sure you can see it. You can see that it's in this first one. It says example of rotation of something 90 degrees clockwise. So you can see here there's some point A that's -7 and 4. And we're to rotate it clockwise 90 degrees. Now, this is an example of how one can do it. When somebody's rotating something 90 degrees, what you want to do is you want to take the x-coordinate, which you can imagine is the very first number, and you want to multiply it times a -1. Now, if you do that, what that effectively does is flip it, right? And if that's the case, then a -7 times a -1 will end up becoming a +7. Now we leave the 4 coordinate, the y coordinate, alone. Now if we do that, of course, we get 7 and 4. But then in order to do an actual rotation, not only do we have to flip the sign of the x coordinate, but then we want to switch them. So we will move the 4 first and the 7 second. And of course, if we do that, we get a number 4 and 7. So to rotate the point -7 and 4 clockwise 90 degrees, you'll get point A prime, which is 4 and 7. Now, to show you what that actually means on a graph paper, I'm going to go ahead and pull in a piece of graph paper here. And you can see then that if I plot point A -7 and 4, -7 is the x-coordinate, so that is 1, 2, 3, 4, 5, 6, 7 points minus, and then 4 positive points up. 1, 2, 3, 4. So on our graph, that point is here, and that is -7 and 4. Now, if we wanted to rotate this thing 90 degrees clockwise, well, you can imagine clockwise is in this direction. So what in the world would that be? Well, if I were to take my handy dandy pencil here and I were to draw a nice line over towards the origin of our graph, you could probably see what a 90-degree angle is going to look like. A 90-degree angle is going to look like 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7 over here. Then if I draw a line here, you'll see how that looks like a nice right angle that's been rotated over. Well, you can see that this point here is 1, 2, 3, 4 over on the x-axis, and then 1, 2, 3, 4, 5, 6, 7 up on the y. So just from a graphing standpoint, you can see that 4 and 7 is the 90-degree rotation of -7 and +4. But how in the world could one go about actually doing this without using a graph? Well, what you simply do then is like we showed before in the example. You take the minus 7 times a minus 1. If you do that, you're going to get a positive 7. You leave the y-coordinate 4 alone, and you get positive 7 and 4. But then if you switch them, and you move it to, instead of 7 and 4, to 4 and 7, then A prime becomes 4 and 7, which is, on our graph, 4 and 7. Now, interestingly enough, what if you were to take that same exact 1 and you wanted to rotate it the other way, or 90 degrees counterclockwise? Well, you can see here that 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7 would be here. So this would be minus 7 and minus 4. And then, of course, you draw our nice line towards it. You can see that that is then 90 degrees counterclockwise. So how in the world could a person duplicate what's going on in our graph here? We'll scoot this over. Well, you can see this time, since we're going counterclockwise, we're going to multiply the y-coordinate by minus 1. So we'll leave the minus 7 alone, and this time we'll take the 4, multiply that times a minus 1. Now if we do that, we'll get a minus 4. So minus 7 stays, and then 4 changes to a minus, negative 7 and negative 4, and then of course in the final step, switch the x and y coordinates around, so it's minus 4 and minus 7. Okay. Oops. Yeah, it'd help if I wrote that down here, wouldn't it? Sorry about that, everybody. That's a little mistake on my part. Yeah, minus 4 over and minus 7 down. That was supposed to be the way it is. What a goofball. Shows you how out of practice I am. So anyway, you can see that minus 4 and minus 7 and 4 and positive 7 are exact opposites in exact opposite coordinates, or quadrants. You guys may remember that this was quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4 over here. These are all positive, positive. This is, you can imagine, negative, positive. This is negative, negative, and then this one is positive, negative. So that's what an actual, rotation is. All right, so I'll go ahead and help you with the first one. So let's take a look here. Point A is 1 and 5, and it says we want to rotate this 90 degrees clockwise. So we're going to use the first example, and that means we're going to take the first number here, the 1, and we're going to multiply it times a minus 1. So if we do that, it'll be 1 times a minus 1. Now if we do that, of course, that's going to change the sign of the first coordinate to a minus 1. Now if that's the case, then of course we leave the 5 the way it is. So that is minus 1 and then 5. Now the next thing is switch the x and y coordinates around. So if we do that, we're going to get then A prime is 5 and minus 1. You see how that works? All we really did was we took the first number here, we changed its sign to negative, and then after that we switched them, where the 5 moves to the first number and then the minus 1 with its sign changed to the second number. Now down here with rotating something counterclockwise, we'll take the exact same number and see how that works out. So in this case now, we're using the counterclockwise example, which means we take the y-coordinate and we multiply it times a minus. So if we do that, the y-coordinate becomes a minus 5. So we'll just, for a little mental math, the 1 stays the same, but the 5 changes to a minus. Now, the next thing to do is switch the x and y around, and if we do that, you can see that we're going to get minus 5 and 1. Okay, so in that case then, they're exact opposites of the previous one, rotated the other way. See how that works? Okay, that's how you do rotations. Next lesson will be how to do what's called a translation. But I'll put that in another video just in a second. All right, you guys work on those first 8.